represent a single direction, more symbols represent a family of direction, family of plane, or a single plane, right? What other symbols you can use? And normally, how do we determine the indices? A particular system, cubic system, how do they determine the plane 1, 0, 0, 2, 1, or this, which you can just follow the standard procedure and also use the vectors, like how do you calculate a vector line between A and B, as we discussed last tutorial, right? x2 minus x1, which is an I, vector of I plus y2 minus y1, vector of j, or this. And you can just use the vectors for form. So you use the coordinates, get the coordinates. So the question is, does the coordinate system affect the lattice vector and plane this determination? Whether you can just use in a cubic system, simple cubic system. Is it true that you can only use a simple cubic system? No, right? In any other particular different systems you can use, triplane, tetragonal, right? In cubic system, we use it's just that it's the simplest form that A equals to B equals to C and all the angles are 90 degrees. It is easier to represent the whole system. But any other system, you can also use the coordinate system like 1, 0, 0. You can draw a plane in a triplane system like 1, 0, 0. But this 1, 0, 0 doesn't mean exactly the same thing as cubic system 1, 0, 0. The mathematics behind how to calculate the different planes will be very, very complex, that you don't have to really understand, don't have really to use a mathematical way to prove it. You just need to understand that you can use in any different systems. Triplaning, A not equals to B, not equals to C, and angle not 90 degrees. You can also draw a plane or draw a direction inside, right? We use simple cubic system to represent the whole thing, the coordinate system. Okay? Don't get confused about this. So that is why some people will ask the question, like your friends will ask, like, what in the previous tutorial question, there's an A in between, A before that you calculate when you calculate the distance between A and B. So we use unit vector. Normally we use unit vector 1 to represent the lattice constants, right? When the lattice constant is not equal to 1, it's not the unit vectors, then you need to use the A to represent the lattice constants. That's why the distance between A and B, you need to put an A. Yeah. Right? The same thing in other different coordination systems, it's just the calculation may get very complex. So can you write down the plane indices of this? Should be very fast, right? This is a simple example. I write down the plane of this. Can you give me the answers? Really fast to get it out. Right? Answer is? Anyone? One. Minus 2. Right? Why? We discussed the last tutorial, right? In any directions, you can use the multiplier. For planes, you need to use the reciprocal. Right? Positive 1 minus half. To represent the plane, you need to use the reciprocal of half, which is minus 2. Right? Any questions? Direction should be very simple, right? Alright. The concepts of family directions, family of planes. And what is the definition of linear density? Yeah, it is a slide to show you the definition, the formula, right? What is linear density? Number of atoms on a particular line vector, right? What is planar density? The definition of this. Alright? Don't get confused about this. And also, as we discussed, I think last tutorial also, the atomic packing factor was the definition. Right? And what are their units of linear density and planar density? What we are trying to emphasize here, as we mentioned, this atomic packing factor is the atomic packing factor is the is dimensionless. It's because of the unit is the volume fraction, the volume of atoms in a particular unit cell. So there's no dimension. But for linear density and planar density, there's a dimension, right? In the number of atoms in a particular line vectors, and number of atoms in a particular plane, right? You need to take note of that. In the next tutorial will be a lot of calculation on the atomic packing factors. And how do you count the number of points falling on the line of the areas? What are the points are sharing? What are the points are not sharing? How do you calculate that? Right? In the tutorial questions, we will cover that. And zoom axis, why zoom laws, which we want to emphasize here is that it can be used in a lot of different any crystal systems. It's not necessary in a qubit systems. It's because that we just want to use this as a calculation method to help us to get what we want. It's just a 3x3 determinants for us to use as a calculation method. And in any other, because simple qubit, as we mentioned earlier, the simple qubit system represents everything in the easiest way. But we consider other systems like triclinic to prove that this is equal to 0. It also can be done. It's just the mathematical way to prove that is very, very complicated. We don't have to really know the mathematics behind. We just need to know how to apply this, right? How do you use this one zoom law is to determine the zoom axis from a group of planes, right? As we discussed last tutorial. The other one is used to determine the plane indices from a group of lattice vectors, right? You know there are two vectors, and they're both from a plane, they form a plane. Then you find another plane indices. You find a plane indices of these two vectors, right? How do you use this as a function, so-called a tool to help you to solve the problems? So you can go back to your tutorial one, the last two questions, to sort of get an idea of how to apply it, and it will be easier for you. And the last concept you need to understand the unit cell volumes, the lattice constants, as I just mentioned, the A lattice constants in a simple qubit system. A, just use A, right? And in different type of this system, A, when A equals to B, like trigonal, when equals to A equals to B, and A not equals to C, how do you calculate the unit cell volumes? All these in different systems. And the lattice vector length, angle between two vectors, angle between two planes, p spacing. Those are all the formulas given in your formula book, if I'm not wrong. Formulas are given, so you can find it for different type of systems for tetragonal. So the d spacing you see to calculate it will be much complicated compared to qubit, but you can actually find it and you apply the formula in your exam. So just take that in mind, all the formula are given, the calculation formula given. So there will be all the concepts that you can have a better understanding on the lecture notes. That's all the basics concepts that you have to take that in mind, and how do you apply it to solve your questions. Okay? planes in the tetragonal crystal and group them into family planes. Right? That's referring to electron the 6 combinations, right? And on a tetragonal system, we know B equals to B not equals to C, right? So when you draw it out, the planes are parallel to A and C, to A and B. They are identical, right? It's because A equals to B. So when you draw the plane that parallel to A axis and B axis, they are identical. But when you draw the plane that parallel to C axis, and this body diagonal plane, they are not equals to the plane you draw just now, mentioned just now, right? This plane are definitely not the same as this plane. But these two are identical. When you just rotate 90 degrees, it will be exactly the same thing. It's just a matter of you define origin. Right? It's the same thing. So these can be grouped into a plane family of 011, and these can be grouped into a plane of family 110. That comes out from the characteristic of tetragonal system, which A equals to B not equals to C. So A and B axis, the plane parallel to A and B axis are identical. Any questions? No, let's move on to the next question, which tetragonal crystal system have a constant of A and C, so A equals to B, equal to C, and calculate the D spacing. This question is actually quite straightforward, right? You can just apply all the formulas given, you can find it on the lecture notes. What is D spacing for tetragonal system at each different plane? So 1, -1, 0 would be this, substitute the numbers inside, you get this value. And for the second plane, 101, plug in the number, you get it. Question 2 is pretty straightforward. You can just use the formula, apply the formula, put in the numbers. Alright? So the last question, it will be the angle between the two planes. You can also find the formula on your lecture notes. Angle between these two in a tetragonal system, apply everything inside our number. And get the value of 49.46. Any questions? No? Let's move on to the next question. Question 3 and 4. It's actually similar, right? Ask you to calculate the linear density and the planar density of a particular direction on the different type of lens system, FCC and BCC. Remember, this has a function of the atomic radius of R. Last tutorial, we discussed about how to find the relationship between E and R in different lattice system, right? For FCC, BCC, you guys remember? What's the relationship between E and R? So for FCC structure, this is your phase plane. So you have an atom on the corner, atoms on the corner, atom on the phase center. So your relationship between these would be square root 2a, let's constant is a, equals to 4r, right? R. That's for your FCC. And for BCC, this is your body diagonal, right? The body diagonal equals to square root 3a. Any problem with that? No, right? Straightforward. Square root 2a, a equals to 4r. So that's your relationship between a and r. Okay? When you get the relationship between these two, the rest is just to find how many atoms on your particular direction, right? Divided by the vector. So for the first direction is 1, 0, 0. So the answer gives you the 1, 1, 0. 1, 1, 0 is the phase diagonal. Right? So will be 2 atoms, half atoms over here, half atoms over here because they're sharing. Right? You can't just use particular one whole atoms over here. So the whole atom over here, so there will be only 2 atoms, then divided by 4r, then you will get answers, right? So this is 4r. And for a line over here, which is just equals to the 1, 1, 0, 0, direction 1, 0, 0, which is just equals to the lattice constants a, it will be 1 over a, right? We just apply what we get just now, the relationship between a and r, and you can get a function of r. Any question? 111, the body diagonal direction over here. How many atoms are there? In the body center, there's no atoms, right? Only atoms at the corner. So it's 1 divided by square root 3r, which is the square root 3a, sorry, which is the body diagonal distance. And you get the relationship between a and substitute the relationship between a and r, you get the function of r.
Why not 2 atoms?
Why
Why not 2 over square root 3a?
Yeah, particular one atom at the corner here and one atom at the corner here. In the center, there's no atoms. Right? It's phase center cubic. Right? But they are sharing, right? They are sharing with another lattice. You can't just use 1 plus 1 equals to 2. It's the same thing, you calculate how many atoms in your FCC structure, BCC structure. It's pretty similar, right? The atoms at the corner, when you atom in the corner, she's sharing how many unit cells? And how do you calculate that? The atoms on the face is sharing with another unit cell. How do you calculate that? So for FCC, how many atoms are in the FCC structure? Have you guys learned that? Is in last week's lecture or in the next week's lecture? I'm not so sure, but is the how you count number of atoms in a particular different systems, FCC and BCC, simple cubic, hexagonal, okay? You will learn. Don't worry about that. So you compare the numbers, then in direction of 110 is the highest, right? What does this mean? It means it's the higher packing density direction. You have to know what does this tells you about a higher packing density, which you will learn it in the following lectures all the way until the end of the semester. Like higher packing density, direction of plane, will affect your defects, all these. Alright? In split systems. Don't worry about that in your last part of the lecture. And for question 4, which is the planar density. So it gives you 3 planes structure. As we mentioned just now, in the BCC structure, what's the relationship between A and R? So it's square root 3A equals to 4R, right? So what you need to do is to find a family plane of 1, 0, 0. How many atoms are there? Divided by the area of the plane, right? As we mentioned just now, get the relationship between A and R, put it inside, you get the function of R. Now you can see the units, right? Just now is 1 over R, now it's 1 over R squared. So 1, 1, 0 family plane is the body diagonal plane over here, right? Can you imagine? One is here, the other one you can also draw here. The family plane of 1, 1, 0 is the body diagonal plane over here, which contains 4 atoms at the corner and 1 atom at the center. Okay? Same thing. Atoms divided by the area of this. The area is square root 2A times A. Then 1, 1, 1 is a little bit complicated. Do you know why? You need to know whether these body center atoms are lying on the surface, right? Whether it's lying, you guys know whether it's on the surface or no? No, right? You need to prove what? Whether it's on the surface, right? You can't just say no. Why? And you prove it is on the surface or not. That's the tricky part that you need to understand. Once you get, as we mentioned just now, it's not lying on the surface, so you can just apply everything we just discussed, right, to get the answers. But how do you guys don't understand the area of the triangle over here, right? The base is square root 2R. The height of this triangle will be square root 2R times sine 60. So half of base times height will be the area of the triangle. So how do you prove that? Whether these atoms or this particular point is not lying on the plane? Any idea? It's actually in your vector algebra notes, slide 30. To prove that the point whether it's on the plane. So expand everything. That's how you prove it, and you refer to the lecture notes. Is for a point on the plane, you can actually find the line vectors, right? Which actually is the normal vector of the plane. At a particular point, they are perpendicular to each other, right? And this is your normal vector of the plane, and this is your point line vectors. Right? So you get a new equation of the plane equals to a constant, and you substitute the points into this new equation of plane, see whether it's equals to a constant. If it's equals to a constant, it means your point is on the plane. If it's not equals to your constant, that means the point is not on your plane. Let me go back to the slides. So just refer to your lecture notes. You get the normal vector of a particular plane, and for a point over here, you get a line vector of this, right? From P0 to P. Understand, right? This why is this? We said about the distance between A and B from line A to B. Right? So you use the dot product of these two must equal to 0, and you can get the new so-called plane function, the plane equation of 1, 1, 1. When you substitute 1, 0, 0 inside, equals to, you get the constant, which equals to x plus y plus z equals to 1. You can plug in any points of the triangle here, the plane here, to get a constant. Once you get the constant, then you try to put the point that you're trying to prove, which is half, 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 inside this equation. See whether it equals to the constant. If it's not equal to the constant, then that means it's not on the plane. You get what I mean? First step is to write the line vectors, right? From one point to another point. You already know the normal vector of your plane. When you write the line vector of this plane, when you use the dot product, they must equal to 0, which they are perpendicular to each other, which is why it's not wrong. Yeah. Right? Then you put any point inside this to get your particular equation of the new plane to get your constants, which is x plus y equals to plus z equals to 1. That's your new equation of your plane with a constant. You substitute the point you're trying to prove, which is half, 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 inside this particular equation. Then you find they are not equal to your constant you get. It proves that the point is not lying on the surface and lying on the plane. Okay? This part understand, right? Normal vector of your plane. We discussed last program. Just assume this is the point that you're trying to prove when it's lying on the plane. You get a line vector. How to determine the line vectors I, j, k, which use this point to minus this point of I, y minus this y0 of j, right? This is the line vectors. When you use the dot product, which applies the White's law, it must equal to 0 because they are perpendicular with each other. So you get a new equation so-called here, n equals to 1, 1, 1, 1i, 1j, 1k. So you substitute any points of 1, 0, 0, for example, inside, you get a constant equals to 1. Then you find the points that you're trying to prove, which is half, 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 substitute inside. When it's not equal to your constant, that means it's not on the plane. Okay, a little bit tricky. All right. Question 5 and 6 is basically to test you on the understanding of how to apply to White's law. You remember what we discussed, right? We can calculate the zoom axis of two different planes across each other, non-parallel planes, and the other one is using a two line vector to find the planes that these two line vectors are lying on, right? So can write down the family of direction of over here. In 6 directions, you can just apply every single one of them with the normal vector of this plane. When it goes to 0, means what? Means it's on the plane, right? So you find out these 3 are lying on the plane. The same thing, you use these 6 directions, apply the Poisson law with this normal vector of the plane 1, 1, 1, and then find these 3 are lines on the plane. Question 5 and 6 are exactly the same thing to test you about how to apply the Poisson law. Okay? As we mentioned, it can be applied in any system. It's just that the 1, 1, 1 does not mean the previous system 1, 1, 1. Right? There are a lot of mathematics behind that. We don't have to really to understand, it's not in your test scope. So when we merge these 2 together, it actually -1, 0, 1 is the so-called zoom axis of this plane, right? You recall your tutorial 1. They are sharing the same zoom axis of -1, 0, 1. So question 6 also the family of direction of 1, 1, 1. But the family direction of 1, 1, 1 only have 4, right? You just apply whatever is 4 with the normal vector of this plane. If it is equal to 0, then that's your planes lines on the direction lines on the plane. And it's the same thing. Okay, just apply the Poisson law. Any questions on this 5 and 6? Don't worry about the mathematics behind the Poisson law. Just use it as a tool to help you calculate. Okay?
one because so this he never tell us about this one. But do you understand this?
What force you mean is like, for example, if Maxi is not or Maxi is one, so if like you never key in the number, so there's no maximum. So if you key in
The first number if you register, then after that keep comparing again.
yeah, something like that.
He never did the term is someone.
I don't know. I'm also very confused on this. But do you remember what he said for the quiz?
Oh, it's written on the paper.
Then it's like you have to he gives something like this question that
This is only one question like this, the final last question. But before that, all of those majority is like quite easy. It's not everything like this problem only one question about grammar. The rest is like he never say like what they say should be short answer whether you think true, false or like the
he give like he give the coding and he give this stuff, then we say the result is correct or not.
You know the lens quiz, I think like that, but this time round without multiple choice.
Just right. And then you know how to get this 5 very small guys. How to get this?
Oh no, this one this is total right?
Cannot get
This one you need a piece of paper, then you can understand. Hold on oh it's okay. So you see the first time so let's say I input my number, now it's 1, total is 0. So I print before the first time print
is the number the one.
means before 1 is number is 1. Then keep repeating so after that total is total plus number. Now your number is 1 right? So your total is 1 now. Total plus number plus 1 means now your number has become 2. So you print what number is 2. Then you repeat again. Then total become 2. Total plus number 1 plus number 2. Total become 3. Sorry.
So 741 total.
Because your number always here is 2 already. So total plus number. Your total was 1 plus number it becomes 3.
So then now 3 I skip right?
No, this is total, not number. So one more time number. Your number is 2 plus 1 now become 3. So one more time. Because now number is less or equal 3, got the equal sign. So you repeat again. Total now 3 plus number 3 become 6. That's why the total is 6. After this already, the number is 4. 3 plus 1, so it becomes 4 already. It's escape from the 1.
So the print the total here is referring to this total. Okay. Thank you. So confusing. I know this one.
This one I haven't go through. He's going through.
You know this question? The rules
I study until problem 1 then I haven't continued.
Yeah, I don't know why. This question, do you understand?
I haven't go through this problem.
You see. I wait for you. When is your session? The first one or second one?
So first one, second one.
Also second.
I never see you with.
I sit inside. Hey, you want to know the thermos?
I don't understand.
The one got thermos. I don't understand. He said,
I don't understand the problem.
what kind of the one for?
This one? This one is for what? Water is open book.
Yeah, it can search in there. Cannot, right? Cannot.
He say connecting to Wi-Fi is okay, but just don't use social media, don't use chat. Internet wise,
No.
Grace or I see how I don't know, I think definitely got people cheating one.
But I don't know.
I also don't know. I understand the function continue. Oh, continue is like repeat. In this one continue is like repeat, start over. Yeah, but I like.
But in front is break, you know.
Huh?
In front this one got four right? My friend tell me this one continue is break.
Break?
What
is the difference between break and continue? Continue means you break
Must see the
but you start
situation.
over. Break means you break, forget about the loop, continue to the next thing.
You mean this
Yeah, because they got two types of break.
we go through one time and then you say my answer. Maybe I go through